Right, I just wanted to show you this crystal filter that I've been making, and I'm trying to figure out what the bandwidth and what the characteristics of it are. I've got the DDS that I was fiddling around with previously hooked up to the input of the crystal filter, and then the output of the crystal filter is feeding into my scope up above here, which is in turn feeding at a dead 50 ohm output into the spectrum analyzer, which seems to be drifting a little at the moment, but right now we're on 9.99766 megahertz, the frequency that's being generated by the DDS, and you'll see that we've got quite a big peak showing the RF on the spectrum analyzer. So what I'm going to do is I'm going to just start to lower the frequency fairly slowly, and as the frequency drops, you can see it's moving to the left on the spectrum analyzer as you'd expect, but you can already see the characteristics of this crystal filter, because the amplitude of the RF that's getting through is dropping all the time. Now remember that this spectrum analyzer is a logarithmic instrument, so already from where we started at around here somewhere, kind of there, where we're at 9.9976 megahertz, when we've dropped down to around about here, we're already at least 20 dB, if not more, further down, attenuation going on here. Now remember that 6 dB is half voltage, so that's more like 26 dB. So the scope that you can't see, but the scope has gone from showing a very clean sine wave to just showing a bit of noise. I'm sure if I altered the volts per division we could see something on the scope, but there's a lot of attenuation going on there already, and all I'm at now is 9.99687 megahertz. So if I continue to drop this down, you'll see it drops and drops and drops and drops and drops right until it's so far in the noise it's just not worth talking about. Now this spectrum analyzer is currently set at 1 kilohertz per division, so I'm only 2 kilohertz lower, maybe a little bit more, but 2 kilohertz lower from where I was at my peak. So what I'm going to do now is wind it right the way through again, and we can see that it rises and rises and rises and rises and rises until we get, there's a bit of a dip there, and then it seems to rise again till we get to what's around the center frequency, which seems to be around there-ish, which again is 9.9976 megahertz. And if I increase it this time, you'll see that it drops off quite sharply, then picks up again, and then starts to drop off incredibly quickly on the way down the other side. And that's about the same sort of distance the other way. So we're right back down in the noise over here again now. So we're 2 kilohertz above the center frequency. So that's what I wanted to show you. Bye.